In this video, we'll demonstrate a layered approach to developing a manufacturing task simulation where each task goal is added and tested one goal at a time. While not included in this video, once a task has been simulated, a wide variety of tools within the Santos environment can be used to evaluate exposure to risk of injury. For more information on how to use end effectors, marker targets, and collision avoidance tools and techniques used throughout this demonstration, please refer to the masterclass videos on those topics available on the SantosHuman YouTube channel. Links to those videos are provided in the description of this video. The first step in this workflow is to use a marker target of type bounded plane to do two things. The first thing that we want to accomplish is to identify the region where one of the two workers will stand when removing the plank from the table. The second thing is to simulate a half-inch thick shoe sole below the ball of the worker's feet. The marker target position is going to be set half an inch or 12.7 millimeters above the ground plane. Naming marker targets, end effectors, etc. as they are being created can be a useful organizational aid. Then set the marker target type to bounded plane. Then we are going to orient the bounded plane marker target parallel to the ground plane. Set the radius of the bounded plane to half a meter. Then move the bounded plane to an approximate location where the worker will stand. We use end effectors to identify points on the body that must be in contact with marker targets in order to successfully complete one of potentially many task goals. Placing 3 end effectors on the ball of each foot, and then associating those end effectors with the bounded plane marker target creates our first task goal, which can be referred to as standing within the radius of the defined boundary. Remember to name your marker targets, end effectors, etc. as you create them, as they can serve to be a useful organizational aid. We're going to test each task goal as it is being defined, since that makes it easier to troubleshoot issues that may arise, including input errors or over-constraining the model. Here we can see the predicted results are reasonable, as the avatar is standing on the balls of its feet, allowing the ankles to provide additional height if necessary, and both feet are within the bounded plane. However, not all the end effectors are automatically associated with the correct joints, but that's something that's easy to fix, and it will provide better results. Now we can go ahead and add the second task goal of the simulation, which can be referred to as grabbing the edge of the plank with the right hand. While the pad of the index finger is in contact with the top of the plank, the grasp and hand orientation have not been defined and the avatar's body is passing through the table. To accommodate for this, we're going to add the avoidance of collisions with the table to the task goals. This is something that's easy to do, and we're going to do that next. For details on collision avoidance, please refer to the SantosHuman YouTube channel masterclass video on this topic. It's unnecessary to expend the computation time to avoid collisions with the entire length, width, and height of the table. Instead, we can focus the Santos predictive models on the relatively small region where the worker will stand when performing the task. Before any object can be included in collision avoidance calculations, it must first be filled with collision spheres. For more information on this, see the masterclass video on collision avoidance. Neither the object or the collision spheres need to be visible to be considered. Once they exist, they are always considered until they are removed. Now we can see that all predicted task solutions will now avoid collisions with the defined region of the table. Most tasks will require the ability to see what is being done, and since this is easy to do, and always looks better, we'll include it as an additional task goal. The order that task goals are included isn't typically important, but now that the obvious issues have been addressed, let's continue the development of the grab onto the plank with the right hand task goal. A variety of methods for defining grasp strategy exists, including predicting them, but since a grasp from a similar effort has already been saved, it can be reused here. Since the grasp is not being predicted, a hand orientation must be included as a task goal, and this option allows that to be specified manually. When the hand orientation lock option is on, predicted solutions must include the current hand orientation, roughly defined as the direction the palm is currently facing. Now that the right hand grasp and orientation are set, a few minor tweaks to hand position are required before moving on to the left hand. Developing task goals for the left hand will be identical to what has already been described for the right hand. As you watch this section of the demonstration, try to anticipate what is required, and we'll jump in to note the steps that haven't already been shown. Just as the orientation of the hand can be specified manually, so too can be done with the hand direction. Please note that in the video, the option is mistakenly set for the right hand, and it takes a moment before the error is detected, but it's then corrected shortly. Turn on requirements, or set to true, to always be in balance for posture-constrained ZMP, and to also respect the currently defined strength profile, posture-constrained torics. Here the human performance objective functions are weighted to give more importance for the avatar to see and to minimize effort and joint displacement while also reducing the importance of minimizing torque at the joints. Please note that we forgot to allow the predicted solutions to reorient the virtual worker's body and hips, and it took a moment to figure out why those results looked odd. Now that the rotation has been unfrozen, the results look much better. Given that the predicted solutions are pushing the virtual worker to the edge of the defined boundary, there may be better solutions a bit further back. Setting the orientation and direction of the hands relative to the marker targets allows the defined grasp strategy to follow the plank as it is being rotated off the table. While not included in this example workflow demonstration, an extensive suite of assessment tools are available within the Santos environment that can now be deployed to the following. Determine if a worker of this size can perform this task. Determine if a worker of this size should perform this task. Determine size and strength requirements for workers that can perform this task safely n times per day. Determine the percentage of a population that can perform this task safely n times per day. And conduct trade-off analyses to determine if proposed design changes decrease exposure to risk of injury and/or increase the percentage of this population that can perform the task safely.